Uh, am I audible? Hello? Could someone respond in the chat? Okay. Okay, fine. We will start the session in a while. We'll just let other people join. I'll start in about 5 minutes. Hello, is my screen visible? And I am audible? And am I audible? Okay, right. So let us start with today's session. Hello, everyone. I'm Suraj, coordinator in the programming club. Today, we will be looking over some elements in object-oriented programming systems. So let's get started. Right. Okay. So what are you going to do today? We will look at encapsulation, then we'll go towards abstraction, which in a way paves to polymorphism, and then overloading. These are all just some elements in object-oriented programming systems, which you'll be using quite often when you're going to be dealing with large softwares and programs where multiple people are working and you don't want to repeat yourself. You don't want to just copy paste multiple lines of code. You want to have code in one place and use it everywhere, or where in the cases where you want to hide certain information from the end user. You don't want them to look at every nook and cranny of your code. So let's get started. Right. Encapsulation. So encapsulation, as the name suggests, it is integrating all the data elements and methods into a single capsule as a single entity, so that it is easily accessible and it is easily debuggable, as everything is in one place, so you can just see all the dependencies that are required for the particular program to just debug if there is some bug in the program. So data members can be accessed and modified method and modified by the methods of this class. We use access modifiers to do that. From the previous sessions, you might know what access modifiers are, but we will be going over them quite briefly in this session as well. Encapsulation also paves a way to another technique in object-oriented programming called abstraction. We will look at that in today's session as well. And the data members are usually made private so that they are inaccessible without the methods of that class. Okay, right. So just pay attention to the wording here, encapsulation, and that will just indicate what it is all about. You're just enclosing everything that is relevant into a single capsule. That's all it is. Right. Why do you want to encapsulate? We have more control over the code in general because everything related is at a single place. You can just see what is happening without having to go through multiple files or multiple lines of code at once. You can just see what all is related to the program at a single place. Only essential details are visible to the user, and hence security is increased. This is more of an abstraction. This point is more related to abstraction, but it is abstraction and encapsulation are related in some way. So we'll just use it here as well. Right. Reduces redundancy and decreases debugging time. This is the most important reason why we use encapsulation, because everything is organized in one place. We can just debug them easily, and we can use the same code over and over again without having to repeat ourselves by copying and pasting it everywhere. How hectic would it be if you find a bug and you have to go through the code everywhere that you have used it and you have to change the lines of code in those files? Why not just change it once in the main file and let it apply everywhere, right? And it in general just improves readability and maintenance of the code. It just makes our life much more easier generally. Right. Let's look at access modifiers. Access modifiers make it so that we control what is visible to the user. So I think we have covered up access modifiers in the previous sessions, but we'll just look at it again. Public access modifier makes it so that it is accessible by any code where that class, let's just say, is used. Private, the data members used with private access modifier can be accessed only by the member functions of the same class. And protected access modifiers makes it so that the data member uh, can be used by derived classes as well. It is somewhat of a laxed version than private. Okay, so let's move on. Does anyone have any doubt? Okay, right. Let's just move on then. Let's look at an example. I've just created a basic class called encapsulate, where I have a variable x, which is set to be private. And this is in general called a getter and setter, which is quite popular. You can just look it up if you want. But yeah, these are getters and setters. These are the methods through which you can access the variable x. And if you directly try to access the variable x through any other means, like let's just say you do object.x, then it will just lead to an error. You won't be able to access it. These are the ways you can in which you can access the private variables and modify them. Right. So this is a setter which sets the value of the variable x, and this is a getter which returns the value of variable x to be used in your other programs. So yeah, we are using the private access modifier over the integer variable x, and we are creating two methods, set and get, to access this. And main, we are just creating an object of this encapsulate class, and I'm setting the object. I'm setting the variable x to 5 as the set method accepts a variable, accepts a parameter integer x, and that is related here. This line of code uh, refers the value that we're giving in this function to this value x. So this keyword, it's pretty important. It uh, indicates that the value that we are assigning it to is from this class, and this x refers to this x. So this keyword is pretty important, right? And this is the arrow function, which you might have learned in the previous session. Yeah, so we're just setting the value of the integer variable x to be 5, that is this x, and we are just printing the value to the terminal. We can't, yeah, as I've stated here, we can't do something like cout object.x as x is private here. It will lead to some error. And to get the value of whatever the object, whatever the data type here is in the private, we are using the get function, which and we're just outputting it to the terminal. We're just doing cout object.get, right? And obviously this returns find a terminal. Yeah, that's all. So let us look at abstraction. What is abstraction? It means displaying essential information to the user. Like, you don't want the user to see how you have implemented a certain function. You just want them to use this function and not be able to modify it or look at how you have implemented it. So that is where abstraction comes into play. So as you might notice, abstraction and encapsulation are kind of similar because you encapsulate something and then use the abstraction principle. So yeah, it is particularly useful when working with sensitive data and you don't want the user to access the items that are not associated with the rules. Like it's something like in Discord, if you have used, you want some permissions to certain exclusive people and some other permissions, you don't want them to be accessible. You don't want them to have those roles, not be able to use those functions. That is where abstraction comes into play. Uh, yeah, as I said, it is also useful when you just want the user to concern themselves with the task and not the implementation of how it is done. You just use it and just forget about it, not care about how it is used. Right. Types of abstraction. Data abstraction. As the name suggests, you hide unnecessary data from the user, like sensitive data. You don't want the user to have direct access to it, like using the keyword private. Yeah. And control abstraction. Hide the unnecessary implementation of methods from the user. Like as I said, uh, you just want them to do the task and not worry about how the function is implemented. For example, uh, for example, some functions in your standard C++ library. Let's just take power function, max function. You just use it. You don't worry about how it is being implemented. Obviously, that is pretty simple, but yeah, let's take some more complicated function. You just want to use it, right? You don't care about how it is implemented. So that is where abstraction comes into play. So how to achieve abstraction? Before this, does anyone have any doubt? I'll wait for about a minute. Just type in the Teams chat here. Okay, all right. Let's just move on then. how to achieve abstraction using classes and access modifiers. Like I said, it is pretty similar to encapsulation, and they are related in some way. But let us remember, encapsulation is essentially keeping all the data members together, while abstraction is making some things inaccessible to the user. May it be implementation or some sensitive data. We don't know. So that is where they differ. That is where abstraction and encapsulation differs. Yeah, so we can achieve abstraction using classes and access modifiers like private and protected. Uh, Using header files, we will look at this. This is a pretty useful way to achieve abstraction, and it is a standard industry practice to use header files to achieve abstraction. This is pretty important. And using abstract classes and virtual functions. We will not go too deep into the virtual functions and abstract classes part because I think it'll be covered in a later session. Yeah, so we will look at these two in this session. Right, let's move on. Okay, abstraction using classes. So let us look at what we are doing. I'm just creating a class called mod, which takes modulo of two integers, x and y, and returns it. Right. I'm creating a function which is modulo, which has return type void. It does not return anything, and it is just doing this operation, modulo operation. We are inputting two numbers. We're taking the modulo and we're just outputting it to the terminal. That's all. This is a class that I've created. As you can see, it is pretty similar to encapsulation, but we just want to hide this in a separate file, or we just don't want them to concern themselves with this, or we don't want them to access XYZ directly. It is a pretty basic example, but yeah, I think it delivers the message. So here I'm creating an object called mod, which mod m, which is object of this mod class, and I'm just calling this m.modulo. In the terminal, it will take two inputs, x and y. This will be displayed. X and y is taken in as input. It'll calculate the modulo and it'll just output the modulo. That is z, and return 0 there. Yeah, that's it. So pretty simple, all basic stuff. Okay, yeah. Abstraction using header files. There was abstraction using classes and access modifiers, pretty simple stuff. But abstraction using header files. Let us look at what this is. We create a header file which contains implementation of certain functions. That is, that you just use and not write it in the main program. You write it somewhere else and you use it in your main program. So here I've created a header file called summer.h, and here I've just written some random function which takes two parameters and returns some operation. This is a separate file in itself. And now in my main program, I just include this header file, right? And after including this header file, I can just simply call this function and not worry about how this function is implemented. And it will just make the code look messy if I have to just copy this everywhere, paste it in the main file, and then use it. It'll be confusing, and you won't be able to edit it everywhere that you've used if you're just copying and pasting it. You can if there is some bug, let's say, in this program, and in the case where you had copied and pasted it multiple places, you would have to change it in multiple places to debug it. But here you can just change something in this header file, and it will be implemented in all the places where you have used this header file. So that is where abstraction really comes handy. So yeah, we can just call this function and we can just use it, and it'll just output some random thing based on the parameters that are passed. Right. So does anyone have any doubt? I'll wait for about a minute. Right, looks like no one has any doubt, so let's just move on. Okay, yeah. Another very common use of abstraction can be seen when we use standard library functions. Let's just say power in math.h header file. You just include that header file and yeah, you just use the function. Yep. So let's move on to the next slide. Polymorphism. So this concept, this is a pretty important concept. It can just make your code look better and allow you to do multiple functionalities calling the same name by just passing in different parameters or in other ways. Like we'll look at that later. Okay, so uh, let's look at the definition. Polymorphism is derived from the Greek words poly, which means many, and morph, which mean forms. So it is right there in the word polymorphism, many forms, which is uh, like it has the same name, but it can do multiple functions, multiple things. Yeah, essentially it means one method or operator can have many different forms, and each one can perform different actions, even though they look the same. Yeah, so just many forms. So there are two types of polymorphism, and they are runtime polymorphism and compile time polymorphism. We'll look at what they are now. Okay, runtime polymorphism. As the name suggests, it is done during the runtime, not during the compile time, obviously. So yeah, let's just look at function overriding. The method definition is overridden in the derived class. We will look at what derived classes are, uh, but okay, let's just go through it for the sake of it. When the method is called by creating an object of derived class, the overridden method is executed. So, right. So let's say you create a class out of another class, which inherits everything that the class has, that the previous class has. Let's just call it parent class has, and you overwrite the function's definition in the derived class. The derived class, when you call the function from the derived class, uh, the overridden method is executed. That is, the definition of the function which you have created in the derived class will be executed. That is called function override. Yeah, as the method is called during runtime, it is runtime polymorphism. Uh, Sadly, you cannot do this in C++, but we will look at an example regardless. But before that, let's look at what derived classes are. A class which is created from an existing class, inheriting all of its functionalities. As I said earlier, you take the parent class, you take all of its functionalities, and then you make another class out of it, which inherits all its functionalities and more. So that is what essentially a derived class is. We add class-specific functions to a derived class to diversify its functionality. Yeah. Let's look at an example. Okay. So let us take this. Let's take this as base class. As I said earlier, you can't do this in C++. It won't execute the overridden method. It will still execute the base class method if you do this in C++. But there is a workaround to that, which we'll see later. Okay, so we have created a base class and we have created a function called run in that base class, which just outputs this. This code is written in Java. System.out.println just means you're just outputting it to the terminal. That's all. And you create an extended class, or you derive a class from the base class using this extends keyword, and you overwrite the method run in this extended class, right? So you just write something random, method from the extended class. And when you run this method from the derived class, using creating an object of the derived class, you will get this. That is method from the extended class. That is, it will run this and not this. That is essentially function overriding. Is that clear? I hope it is. Basically, your overridden function is run when you're creating an object of the overridden class and run that method. This is not run when you override the function here and create an object out of that class. If you okay, let us say I just create an object of the base class and use this method run. What do you think would happen? You can just type in the chat. It's a pretty simple question. You're creating an object of the base class and you're uh, executing this method. You are calling this method. Don't see any responses. Anything. Just whatever comes to your mind. Um, okay, please explain that Java code. Right. So this is our base class. Like this is, let's just call this parent, right? In that, we are creating a method called run, which just outputs something to the terminal. Let's just pretend that system.out.println is just cout in your basic C++. Like I said, you don't have to worry too much about the Java syntax. I'll just explain it to you in C++ terms. So system.out.println is essentially cout, and this is your usual function that you create in C++ as well. And you are extending and you are inheriting all the functionality of this base class into this derived class. We'll just call it extended class. This extends keyword inherits all the functionality of the base class into this class, into the class that is quote unquote named extended class. And there I'm overriding the method run. I'm just changing its definition. Here it was outputting method from base class into the terminal. And now here it is outputting method from extended class into the terminal. And now this thing, a public static void main, it is essentially int main from your C++. So int main, I'm creating an object out of the uh, extended class thing. And then I'm just running the run method. That is it. Is that clear now? And now my question is, what would happen if I create an object out of the base class and then run the execute the run method? Essentially, let's just say I do base class b and I just uh, say b dot run. What would happen? What would be the output in the terminal? Uh, I'm not sure what you're trying to say. It will run the extended class run. No, it will still run the run from the base class because I'm creating an object out of the base class. I'm not creating an object in the extended class. Yep, yep, that is the correct answer. Okay, let's just move on now. Okay, yeah, here extends keyword allows us to inherit the base class. Inheritance will be covered later in the session, later in another session, so you don't need to worry too much about it. But yeah, it's just something that you keep in the back of your mind. Okay, virtual functions. This will be covered in the later session as well, but let's just look at what it is. It is function overriding, but as function overriding does not work well in C++, this is used, but there is more to it, and we will be covering it in the later session. So you don't need to worry too much about it right now. So let's just move on. Compile time polymorphism, function overloading. Okay, so when two or more functions have the same name but different parameters. Okay, pay attention to the word parameters here. The compiler recognizes which function to call based on the parameters passed. Is the definition clear? Basically, two or more functions, have the same name, but they differ in the type of parameters. Right. It is useful when we want to do similar tasks, but with modifications to the task. Let's just say you want to sort an array. You would just call the sort function. But if you want to sort an array in the decreasing order, you would pass in another parameter. That is some kind of comparator. Yeah, that is when this function overloading comes handy, because you don't want to write another function with some another name, as it would lead to a lot of confusion. But as the functionality is essentially same, but you're just passing in another parameter, function overloading comes in handy as it avoids confusion. Yeah, take in the built-in sort function in C++, you directly pass iterator to sort in increasing order by default, or you can pass in a comparator as third parameter to sort it in a specific way. That is what function overloading essentially is. We can overload almost every function, even constructors. You might have learned about constructors and destructors in the previous sessions. Yeah, even constructors can be overloaded, but there are some key rules that we have to follow, key guidelines. Let's just look at what they are. Functions which differ only in the return type can't be overloaded. So as I had said earlier, this word different parameters, it is useful. It is the keyword here. So functions which differ in only the return types cannot be overloaded. It will return some error. Then functions which differ only in array versus a pointer can't be overloaded, as arrays are essentially okay. The array definition is the pointer to the first element in the array. So these two cannot be overloaded, as these are essentially the same thing. So you can't overload a function like this. Correct. Functions with parameter which differ only in the keyword constant can be overloaded. So let's just say you have a function and the parameter has some const int x, and the same function has another parameter which has const, which does not have the const keyword. Const is a constant. It refers to the constant. They can't be overloaded. It just treats both of them as the same thing. Member functions declaration, which the same name and the same parameter type list, cannot be overloaded if any of them is a static member function declaration. Something like this. It can't be overloaded. Let's say you're creating a class and you have a member function which is called fun, which accepts an integer as a parameter, but it has the static keyword, and another function which does not have a static keyword. These two things can't be overloaded. It will treat, okay, this will essentially return an error, as these two things are essentially the same thing. So these are the key guidelines. Yeah, encounter compilation error. As okay, so these are the guidelines. If you follow them, then you can basically overload any function, even constructors. And yeah, let's just move on. Does anyone have any doubt? You can type in your doubts in the chat box. I'll wait for about a minute. Okay. Uh, I'll move on with the next part. Right. Okay. So these are some examples where I've created three functions called add, which just adds the numbers. Notice that all of them have the same name, but they differ in the parameters that are passed. So you can have, let's say, int a, int double b, double a, int b. These can be overloaded as the parameters order is different. These can be overloaded, and you can have multiple parameters as well. So based on the parameters that are passed when the function is called, the compiler decides on which function to call. So that is function overloading. And let's just say I call add 10, 2.5, 5.56, 6.543. It will just output the relevant sums that this corresponds to this function, this corresponds to this function, and this corresponds to this function because they differ in the parameters that are being passed. And the order of parameters matter as well. Yeah, right. But there is an issue with floats. Let's just say you have an add function with float a and float b, and an add function called with the parameters int. It is showing a red line here. Hello, can you hear me? And types. Yeah. Hello. I'm sorry, there was some technical difficulty there. Yeah, we can overload functions with different parameters. Yes, we can do that. Um, all right. Okay, yeah. So can you tell me why there is this red squiggly line here and how we can fix it? First of all, I am audible, right? There was some internet issue on my part, so not too sure if I'm audible right now. Okay, yeah, fine. Yes, it will be counted as function overloading. Okay, yeah, fine. Could anyone tell me why we have this error and how we can fix it? Okay, let's go through it one by one. I'm passing 5.5 and 6.5. What do you think 5.5, what data type do you think 5.5 is? Is it a float? Is it an int? Is it a double? What is it? No. Unfortunately, decimals are taken as double by default. As we don't have a function which accepts double as a parameter, it looks for a way to typecast it. And the compiler does not know how to typecast it. Do we typecast it to float or do we just typecast it to integer, make it 5 and 6? So it gets confused between these two functions on how to execute them. So how do you think we can fix it? We are passing the same parameters. What can we modify when we are passing so that we don't encounter an error? One is obviously we can just pass in an integer. So yes, we explicitly typecast it to float if you are passing in float, and that will be referred back to this function, and then it will be called. So we just add 5.5f, 6.5f. Or if you just want to do it integer, you can just do 5 and 6, and you'll just get the output. This is a small thing that you will have to keep in mind. Uh, except for that, I think everything should be really good. Fine. Does everyone understand what I just did? Everyone just understand what I said? Or does anyone have any doubt? Um, yes, no, thumbs up. Fine. Let's just move on. Oh, okay. What is the doubt? Could you just type it? Oh, no doubt. Fine, fine. So let's just move on then. Okay, I think. Okay, I just told you how we can resolve it. We can just explicitly state it as a float. Operator overloading. This is not very important, but we'll still look at what it is. We can provide operators some special meaning to it so that they perform certain functionality. Let's just say your arithmetic plus operator, minus operator. You can provide a special functionality to it so that it works in a certain way when certain conditions are met. Yeah, when we concatenate two strings, when we use the plus operator, it just joins both of those strings. It does not, I don't know, like geographically add the strings or something. It does not do something weird. It just naturally adds both of those strings and outputs it as a single string. So this is a common instance of where we are concatenating two strings using the plus operator, whereas plus in strict mathematical definitions, it should just add two values, not concatenate. So yeah, this is a common example of operator overloading that you encounter. We can't override these certain operators, that is scope resolution operator, member selection through pointer, ternary operator. This is just something that is given. There is no, there might be some logic behind it, but it's just better to remember that you can't override these operators. Right. So let us look at how we can override some operators and give them some special functionality when certain conditions are met. Right. Let us say let us take the example of complex numbers. Addition of complex numbers is not the same as addition of our real numbers. You add the complex part separately and the real part separately. So that is what we are trying to implement here. We create a class called complex. We create two variables, real and imaginary. Uh, there is a constructor which creates a complex number, assigning real the parameter that is passed here to real and the parameters that is passed to imaginary to imag. By default, it is 0. And if we are passing in something, it will be just assigned here. And now, whenever we use the plus operator on complex number, it overrides the default uh, plus operation, that is adding of the two numbers, and it just executes this method below. This is like the syntax where we can override the operator. We just call in the, we return the data type, we write operator and whatever operator that we are overriding, and we pass in our parameters. I'm passing a complex object. I'm creating some return object that is of the complex type. I'm adding the real parts and the imaginary parts. That is result.real is equal to real plus object.real, and result.imaginary is imaginary plus object.imaginary. That is, I'm adding the real part separately, imaginary part separately, and I'm just returning the uh, complex object. And in the print uh, method here, I'm outputting the real part and I times the imaginary part. So pretty straightforward. So yeah. So when I do this, I'm creating a complex object C1 with real part as 6, imaginary part as 8, complex object C2 with real part as 3, imaginary part as 4. And if I create another complex object C3, which is C1 plus C2, this plus is overridden. Uh, so basically, our usual definition of plus operator is not applied here. It refers back to this function, and it assigns C3 dot real to real plus object dot real, and C3 dot uh, imagine C3 dot image to image plus object dot image. So it is taking this real part, it is taking this real part and assigning it to our C3 dot real. It is taking imaginary part of C1, imaginary part of C2, and assigning it to the imaginary part of C3. And after that, if you just call C3 dot print, it will call this function, which will just print the real and the imaginary part. As the data types here are private and they are being used in the same class, so we can just do this and we can print it normally. And as expected, we'll just get the usual output: 6 plus 3 9, 8 plus 4 12, so 9 plus 12 I. So that is how operator overloading works. Does anyone have any doubt on how this thing is happening? This is just the syntax of how we overload an operator. You write operator plus and the other object, the first object. I assume no one has any doubt. So that marks the end of this session. Please do fill the attendance form and the feedback form. Uh, Make sure to fill the feedback form because it is very important for us to know where we are making mistakes and we can improve upon them in our later sessions. I'll just be on the screen for a while and then we'll just end the session. And in the meanwhile, if anyone has any doubts from any part of the session, I'll try to answer them. I'll wait for about 2 minutes and then we can end the session. Um, okay, just a second. I'll share the attendance QR. Yep, I've shared the attendance QR. Please make sure to, yep. If someone is attending to the YouTube, Could you share the link there as well? I'll wait for another 2 minutes because of technical mishap, and then we can end the session. Float. Not sure what you're trying to say there. Okay, I'll provide the feedback form link as well, just in case it is not working. I'm not sure if it is working. Code Forces group like Adapt. There is no Code Forces group for CodeCrafts like Adapt, as is a software dev camp. I'll stop sharing the screen right now. And a link of what? Okay, I'll share the feedback form again. Okay. Uh, we will share the Adapt Code Forces group later in the WhatsApp. Okay, I've shared both attendance and feedback form, and I think we can end the session. Yep. Thank you.